And the first thing we gotta do, man, look at that 2. That's weird. Why is that 2 there? I'm gonna rewrite this the normal way. Someone's trying to be weird right here and write a weird problem. We got 2x squared minus 18 over x squared minus 4. All right, so we got all these different things we gotta find. Let's first find our intercept, shall we? We'll find our ints. Okay, let's find our y-intercept first because that is the absolute easiest intercept to find. All we gotta do is plug in 0 to all the x's. So I get that. That's an 18, yeah. And we got 0 squared minus 4. And so we get negative 18 divided by 4. That's not an 8. Negative 18 divided by 4. And that's going to be...
Wait, that's a negative 4.
Wait, did I... Oh, that's negative 4? That's what I wrote. What are you talking about? All right, they both cancel out, become positive. Looks like I divide the top by 2 and the bottom by 2. And then I get 2 in... Actually, I'm just getting into the territory of my other problems here. Okay, hold on. Okay. Now we're going to put equals, we got 9 over 2. That's not even a 4 anymore. What's going on here? This is 4 1/2. Okay, so our y-intercept is 4 1/2. I think I should write y-intercept right here so I don't forget. Let's do our x-intercept. To find x-intercepts, we got to take the dude and set it equal to 0. So we're going to go 0 equals 2x squared minus 18 over x squared minus 4. All right, I multiply both sides by the denominator, peace out. So you're really only taking the numerator and setting that equals 0. I move the 18 over, I get 18 equals 2x squared. I divide both sides by 2. What happens? I get 9 equals x squared, and so x equals plus or minus 3. All right, and that is our x-intercept. And that says x equals, so I don't think I'll forget about that. Next thing we got to do is find our asymptotes. Okay, step 2. Got to find our asymptotes. No, I can't write it like that. Asymptote is not spelled with 2 S's. Just so you know. It's 1 S. Alright, so the first asymptote I'm going to look for is the vertical asymptotes. In order to do that, I'm going to take the denominator, set that dude equal to 0. So I get x squared equals 2, and then I get x equals... No. 4. I get x equals plus or minus 2. All right, so we have 2 vertical asymptotes. What? Next, I'm going to look for my horizontal asymptotes. And for the horizontal asymptotes, I look at the degree of the top and the degree of the bottom. The degrees are equal. So what does that mean? What is our horizontal asymptote?
2.
Y equals?
2.
Dose. How'd you do that? We took the leading coefficient of the top, divided it by the leading coefficient of the bottom. The leading coefficient of the bottom is just 1. Bang. Boom shakalaka. Now, normally, I go straight to graphing after that. Do you guys remember what the other 2 points were? Or 2 steps? Yeah, we got to find extra points. And 4 was curvy. We got to make it curvy. Okay, no sharp turns and stuff. All right. We have vertical asymptotes. Got our intercepts. Let's put our intercepts on there. Shall we? We shall. Let's see. 4 1/2 is our y-intercept. So let's put a number right here. That's 4 1/2. Okay, and we got positive 3 and negative 3 for our x-intercepts. 1, 2, 3. 1, 2, 3. I'm being really nice with my x's because I saw into the future that I have 2 vertical asymptotes at 2 and negative 2. So I'm going to put a negative 2 right here. I'll put a 2 right here. No, that's not a 2. That's a 2. Okay, we go bam, 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 bam. Bam, 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 bam. And we have a horizontal asymptote at? Dose. All right, so dose would probably be right about there. So I'll go bam, 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 bam. All right, so there's everything. Now, I have this guy chilling right here. So most likely, the middle is going to look like this. But it could do this, you know? So I better check some other points on that. But let's pick a number in this section and a number in this section and find out what those points are. It looks like I forgot to graph x-intercept right there. Hey, do we really need extra points? Nah, we know that this side is right here like that. And we know that this side is like this. Okay. Well, we know because we already got intercepts. We got x-intercepts right there and there. So I don't need to find extra points right now because I got those points. They worked out. Man, that was nice. Now I don't have to like plug in more stuff. But what about the middle part? Is it going to go like this or is it going to go like this? And you know how we can find out? I can pick points, but there's another easier way to do it. The other easier way to do it is to test symmetry on this one. So I'm going to bust out that tool. Test symmetry? Because if we're symmetrical about the y-axis, we're good with these lines right here. Those are symmetrical right now, right? Yeah. They're like mirroring each other. If we're symmetrical, that means we have to do this. We're going to do like a parabola like that. Okay? You'll never double cross the... I have yet to see a double cross over the horizontal asymptote. I don't think that'll ever exist. But you can like cross over it once. But if we are symmetrical, then it has to be the parabola. Ooh, so let's try that. Let's look at what we got right here. If I plug in negative x to this x, will it change the sign of anything on top? No. If I plug in negative x on the bottom, will it change the sign on everything on the bottom? No, they won't. And the reason why they won't is because when you plug a negative x into an x squared, that equals positive x squared. It's the same thing. So do we have symmetry? Yes. Oh, snappity waggity daggity baggity. That means this is our answer.
Is that y symmetrical?
This is symmetrical about the y-axis. Whenever you plug in a negative x and you get the same thing, it's symmetrical about the y-axis.